Welcome to our first IEEE International Conference on Intelligent Reality. As you know, we have many immersive technology ranging from virtual to mixed to augmented and extended reality. And many of these immersive technology, they do already have a lot of different intelligence built in. And what we try to focus within the intelligence reality is try to apply all AI, machine learning, intelligence into the immersive space. Our first keynote that I would like to introduce is Professor Holyface.
We are indeed getting to a point where we can start realizing this vision of intelligent realities by having devices like the HoloLens, like other devices, actually be able to combine, a lot of technology like computer vision, a lot of hardware technologies, as well as machine learning and so on. All of this together start bringing intelligent reality solutions and make all of this actually really deployable and really bring benefits. Now look at mixed reality devices. That brings us to a complete new level of combination of the real world with the digital world. Really, when you put on a device like the HoloLens, you essentially have lots of sensors that enable the device to sense the environment, to perceive what's going on, and can therefore help you in understanding the context and provide the information and can help you solve a task. HoloLens 2. This is how it looks. It's essentially a much more comfortable device, also more immersive, and has a lot of extra capabilities like fully articulated hand tracking, eye tracking, etc., all built in. Look here. First camera. The first camera that you see here is an standard kind of color camera. This is actually a camera used for video communication. Let's say if you ask remote assistance, you can let someone else see what you are seeing and that way work together. But for the rest to operate, HoloLens has many more sensors. For example, these 4 head tracking cameras. So you see one camera here, another one here, and then combined with this one, there's another one here that has the same field of view roughly, but is a stereo pair. Those are the 2 central cameras that you see here. And then you have 2 additional peripheral cameras. Interested in this, you can obviously try it out. Here's then the last. I think this is a collaboration with my colleague Stelian Koros at ETH and his researchers like Roy Koran. Here's essentially some of the work. So here you see Roy on the left, essentially wearing a HoloLens, and then moving, his hands. The hands are being tracked by HoloLens. The head, of course, is also being tracked by HoloLens.
5G has been important for the city of Dresden when no one was talking about it. So really the vision that telecommunication aspects are going to change the world has been here, has been born.
Well, the personal highlight is that I could see, especially in the keynote, that 5G is now getting real.
It is very close. I mean, we are at the moment rolling out 5G. So we're in the middle of that super interesting phase of starting and getting started. We now have already, it's like 80 stations and around 200 antennas, which we deployed, and it's growing strongly. So it's almost doubling every month.
You have to understand which parts are still missing and where are the business cases. One of the really amazing use cases might be the tactile internet, where we can democratize skills around the world.
Our vision is that the tactile internet will really revolutionize our world. 5G is a first step. We have to cover this from the verticals, from the applications, all the way down to the hardware. And with 22 professors, we can take this holistic approach, and that is really unique.
Welcome to the IEEE Quantum Week. We are thrilled to report that with the international quantum community's outstanding contributions and participation, we have built a first-class meeting to grow the highly interdisciplinary quantum community and help advance quantum computing, science, engineering and technology. The IEEE Future Directions Quantum Initiative would like to thank you for joining the quantum scientists, engineers, entrepreneurs, newcomers, researchers, practitioners, students, and developers at the inaugural IEEE International Conference on Quantum Computing and Engineering. IEEE Quantum Week, or QCE 20, features 9 parallel tracks every day for 5 days. It comprises 10 keynotes by world-class speakers, 16 workforce building tutorials, 21 community building workshops, 49 technical paper presentations, 7 stimulating panels, 30 innovative posters, thought-provoking birds of feather sessions, and virtual rooms to network and relax in the Colorado Room. In its virtual exhibits rooms, IEEE Quantum Week highlights technologies as well as research and development opportunities by over 30 established quantum companies and startups, as well as quantum research labs and institutes.